Hi everyone, here is a quick demo for my course project on combined cycle power plant. The objective of this project is to build a model to predict the electrical energy output of a combined cycle power plant, which uses a combination of gas turbines, steam turbines, and heat recovery steam generators to generate power. The inputs that we got for this project was we have a set of hourly average ambient environmental readings from sensors at the power plant, which can be used in this model. These are the various columns listed here that you can see here on my slide. We have the temperature, the ambient pressure, the relative humidity, exhaust vacuum, and the net hourly electrical energy output. I'm trying to do some data analysis here, and when I look at the data, this is what we have. All the data type is of type float, and I further did some more analysis to see how many records we have. So altogether, like you saw, there are 5 fields, and we have 9,568 records here. And when I check if there are any null values, I don't find any null values, which is good, and we are good to use this data. I further did some more analysis. I did a distribution plot, and this is what I see. It is represented here in the form of a graph. Going further, I did a correlation matrix, and here this table denotes the information that I got, and I further generated a heat map out of this. And here it is very clear that the ambient pressure is at 0, but everything else can be used as is. So what I will do is I will go ahead and skip using ambient pressure, and I'm going to use all the other fields. Now coming to the models that I'm considering to use in this project, because of the data, it is not advisable to use the classification model. So I'm considering using linear regression and gradient boosting. For the linear regression, I did some data pre-processing, and then I tried dividing my data set into training and test sets. So I did a 80-20 split, and now my training data set has around 7,600 records to be used. Further, I am evaluating the performance based on the mean square error and the prediction capability. So I have 2 different results for my training set and my test data set. So if you see here, the mean square error for the training set is 1.6, and the prediction is 86%. And for the test set, it is close to 2. The mean square error is close to 2.08. And the prediction is 78%, which is pretty good. Going further with the gradient boosting, so what I'm doing here is I'm using the squared error approach, and I'm using the 3 different trees, and along with that, I'm trying to use the learning rate of 1.0 and 0.75. So when I run my prediction on this is what I get as my output. And if you can see here, the best output is on 1000 and 0.1 learning rate. So this is what I'm going to use for my prediction next. As you can see in this slide, the performance after evaluation, this is what I get for my training data set and my test data set. So my training data set is 1.8 mean square error, and the prediction is very good at 97, close to 98%. And for the training, for the test data set, it is 2.27 and close to 97%. So yeah, this is my last slide, and I would conclude that using the second approach, which is the gradient boosting approach, I'm getting better results. So I would choose to use that as my training model for the given data set. Thank you everyone for listening.